over time to solve the problems. So let's see some questions, some UTME questions to really agitate our mind and to really test our understanding of this topic. So let's see question number 1. The question number 1 says that which of the following properties is not peculiar to matter? A. Kinetic energy of particles increases from solid to liquid. That is true, because in the solid state, the molecule or the molecules are fixed. So in that situation, the kinetic energy is less. So number 1 is true. Number B, the A part is true. Then the B option, random motion of particles increases from gas to solid. That is odd, because we know that when it's about random, it has to do with what? Irregular movement, haphazard. Irregular movement, haphazard. So in the case of gases, where do you think there will be more of random motion? It will definitely be in gases. So it cannot increase from gases to what? Solid. That B is odd. So let's see option C. Orderliness of particles increases from gas to liquid. That is correct, because the orderliness is more effective in liquid than what? Gas. So C option is also correct. D. Random motion of particle increases from liquid to gas. That is true, because in the gaseous state, the molecules are more random than in the what? Liquid state or solid state. So in that situation, that means the answer to that question number 1 is B. You can see how we've been able to use the knowledge of kinetic theory of matter to determine our answer. So the answer there will be B. Then question 2. The process whereby a gaseous molecule loses some of kinetic energy to a colder body is referred to as, remember, I told you that change of state, you have gases moving to what? Liquid. In this situation, when you have a gaseous body losing kinetic energy as a result of contact with what? A cold body, is definitely going to be what? Condensation, which I talked about earlier. So the answer to that very question will be option A, which is what? Condensation. Question 3. An element X has electron configuration of 1s2, 2s2, 2p6, 3s2, and 3p5. So this is the electron configuration of an element which we have done in our previous classes. So in this situation, this is no longer new to us, because this is what? The orbital way of arranging an element. So in this situation, this is what is known as what? Wave mechanics model. So the question is testing that which of the following statements is correct about the elements. Option A, it is a halogen. How do we want to know whether it's a halogen? Let's sum up all the electrons on the orbitals. 2 plus 2, 4. 4 plus 6, 10. 10 plus 2, 12. 12 plus 5, 17. Yes, it can be a halogen. X can be a halogen because it is 17. Then element that has atomic number of 17 is chlorine, and chlorine is an halogen. So option A can be true. Let's see some other ones. B, it has a completely filled p orbital. It has a completely filled p orbital. Yes, completely filled p orbital. It has a completely filled p orbital. That cannot be true, because even if the orbital is completely filled here, it is not completely filled, because the maximum number of electrons for p orbital is what? 6, and here you have it 5. So that B, option B, can never be true. So C, it has 5 electrons in its outermost shell. So can we determine the number of electrons in the outermost shell by this model? No, we can only use Bohr model. So if you want to use Bohr model, let's sum up all the electrons. We have 17. So by Bohr model, we are going to have 2, 8, 7. So the maximum, the valence electron here is 7. So, but in the question, in the option, it is 5. So option C can never be true. So the option D, it belongs to group 2 in the periodic table. it can never belong to group 2 simply because elements are placed in group based on the valence of outermost electron. And since the outermost electron here is 7, it cannot be placed in group 2. So the answer to this question will be option A. It is a halogen. That is the only one that is correct. Then question 4. Beryllium and aluminium have similar properties because they, first and foremost, you need to know, because it is very pertinent to note each time a question is asked, quickly relate to the topic that is concerned. When you talk about beryllium and aluminium, you know that we are definitely going to, what they are testing here is diagonal relationship, which we have talked about in our previous lesson. Diagonal relationship, that is what it's talking about. And what do you understand by diagonal relationship? It is talking about a phenomenon whereby elements in different groups having or exhibiting similar properties. So in this situation, if we go by diagonal relationship, we know that lithium, that's 2,1. Then we have your sodium, 2,8,1. We have beryllium, that's 2,2. We have magnesium, that's what? 2,8,2. We have boron, that's 2,3. Then we have aluminium, that's 2,8,3. So in this situation, this one is diagonally related to this, while this one is diagonally related to this. What do you mean by a diagonal? When you have a rectangle, for example, or a square, this is what? The diagonal. And you can see the way the arrow is. So that's to show that it is diagonal. So beryllium, according to the question, beryllium is related to what? Aluminium. So they now said have similar property because they are positioned diagonally to each other. That is correct. B are both metals. C belong to the same group. They are not in the same group. D belong to the same period. They are not in the same period. So the only answer that best suits this question of interest is option A. That is a position diagonally. Because I defined diagonally, a diagonal relationship the other time by saying that it is a phenomenon whereby elements in different groups exhibit similar properties or characteristics. So the option A is the answer to question 4. Then let's talk about question 5. If the difference in electronegativity of elements of P and Q is, so they talk about two elements, P and Q, and they told us that the electronegativity difference is 3.0. It should be noted that when you have plus, look at this, the electronegative values of this and this, or the electronegative difference is 3.0. It's too high. So take note, when you have the electronegativity difference as high as 3.0, let's say between the range of 3.0 to 1.2, it is really high. When you have a high electronegative value, it means the two species are polar. What it means that the dipole moment between them is very high. So definitely they will be what? They will be separated into what? Positively charged and negatively charged. So in a case where you have a high electronegative difference between two species this way, it will definitely be what? Ionic or electrovalent. Take note of that. But when you have a small electronegative difference, such as between 0.1 to 0.9, automatically it will assume what? Covalent. Take note of that. And definitely this one will be what? Metal. It's only metal that will exhibit this, while non-metal will exhibit this. Take note of that. So higher electronegative value, ionic or electrovalent. Lower electronegative value, covalent. So let's go to our option and see the one that will suit based on the knowledge or based on our understanding of this concept. So the question says that if the difference in the electronegativity of elements of P and Q is 3.0. The bond that will be formed between them is A, ionic, B, metallic, C, covalent, D, coordinate. So the answer here will be what? Ionic. Because I said that when you have a large electronegative between two elements, then the bond will definitely be what? Ionic. So the answer to question 5 is option A. Then question 6, how many protons, neutrons, and electrons respectively are present in the element cobalt with atomic number 27, mass number 60? So here it is written this way, cobalt. Then they give us the atomic number to be 27, and they give us the mass number to be what? 60. Take note, it can be written like this sometimes. Atomic number is always written at the base, while the mass number is written at the apex. Take note. So in this situation, the question asks us to determine the number of what? Protons. Protons, neutrons, and electrons, respectively. So the question asks us to determine the number of protons, neutrons, and electrons, respectively. So it has to be respectively. So let's determine it. Based on our residual knowledge, we know that number of protons is the atomic number. So automatically number of protons will definitely be what? 27. Number of neutrons. How do we calculate number of neutrons? I said atomic mass is equal to Z, which atomic number plus number of neutrons. In this scenario, what is the mass number? Mass number is 60. What is the atomic number? 27 plus number of neutrons. So let's make the number of neutrons the solvable formula. So we have 60 minus 27. So in this situation, we're going to have what? 33. That means number of neutrons will definitely be what? 33. Then number of electrons. Number of electrons will definitely be number of electrons in this